Hello everyone and welcome to another explainer. If you are a focused, driven learner looking to finally decode the secrets of the Cambridge IGCSE 0606 exam, you are in exactly the right place. Today, we're charting a course through a very specific and frankly notoriously tricky part of the additional mathematics syllabus. We are zeroing in on the modules where the syllabus explicitly states series expansions are not required. Now, on the surface, that sounds great, right? It sounds like it should be simpler because a complex topic is just completely omitted. But actually, scratch that, it's a trap. When Cambridge removes a tool like series expansions, it doesn't make the paper easier. Instead, it just shifts the entire burden onto your deeper algebraic manipulation and your geometric reasoning skills. You have to prove your mathematical maturity without relying on those expansions. Let's dive deep into this today and uncover exactly what the examiners are hunting for when they grade your papers.
Look at this. Series expansions not required is one of the most misunderstood areas in additional mathematics. Now, this isn't just an opinion from a random teacher. It is pulled straight verbatim from the principal examiner reports. And when the chief examiner says something is the most misunderstood area, that is a massive red flag. But, and here's the secret, it's also a massive opportunity for you. Think about it. If the vast majority of students are completely misunderstanding the expectations here, then grasping these core concepts is your literal golden ticket. It's how you stand out. It's how you secure those top-tier grades while everyone else is getting tripped up. We are going to fix that misunderstanding for you right now.
Which naturally brings us to the big question. Why do so many students find multi-stage analysis and securing those vital method marks so incredibly hard in this specific topic? Well, it usually comes down to a complete lack of a structured approach. Students just dive in and start calculating blindly. Today, I'm going to give you the ultimate blueprint to stop doing that. We are going to break down the theoretical architecture of the exam, the precise technical methodology you need, and the critical examiner warnings so that you never, ever leave points on the table again.
Section 1. Core Principles. The Theoretical Architecture.
Okay, so these three pillars you're looking at, precise definitions, causal relationships, and cross-topic connections, these are the absolute secret sauce to high marks. Let's be honest, anyone can memorize a formula, but the principal examiner reports explicitly highlight that candidates who successfully reference cross-topic connections are the ones who achieve significantly higher marks. You have to show the examiner how this specific bit of math connects to the broader syllabus. For example, can you link the algebraic discriminant of a quadratic equation, the b squared minus 4ac part, to the actual geometric reality of a tangent intersecting a curve? Does it cut it twice, once, or never? It's about seeing the whole mathematical forest, not just staring at the individual trees.
And that beautifully illustrates what Cambridge calls analytical depth. This is a framework that heavily prioritizes logical, structured reasoning over superficial breadth. The examiners absolutely do not want to see a scattergun approach. You know the one, where a student panics and just throws every mathematical identity they can think of onto the page, praying something sticks. No way. They want a deep, focused, logical progression of thought where every single line of algebra naturally, inevitably follows from the previous one.
To prove you actually have that analytical depth, you need to hit three distinct cognitive domains. These are the primary assessment objectives that Cambridge uses. First up is knowledge and understanding. This is your toolbox. Do you actually know the core mathematical rules? Second is application. This is choosing the right tool. Can you take those rules and set up the correct equation in a completely novel, weird scenario that you've never seen before? And finally, analysis. Can you break down a really complex, multi-stage proof into its component parts without getting lost or dropping a negative sign halfway down the page? Mastering all three is exactly how you ace this paper. And really quickly, before we move on to how you actually execute this in the exam hall, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel on your Cambridge examinations. Make sure you hit that button so you don't miss any of these advanced strategies.
Section 2. Technical Methodology. The Standardized Sequence.
Let's see how all that theory actually builds into a highly reliable 5-step procedural framework that you can deploy the second you sit down in the exam. Step 1. Identify the key elements of the question. Step 2. Apply the relevant mathematical principles. Step 3. Execute your analysis with crystal clear working. Step 4. Verify your results. Step 5. Present it all in the appropriate format. Now, here's a fantastic quick memory hack for you. Try using a visual story method to encode this exact sequence in your brain. Picture yourself as a lead detective at a crime scene. First, you identify the clues. Next, you apply the mathematical laws of the land.
Then, you execute a thorough logical search of the area. After that, you verify your evidence to make sure it's solid. And finally, you present the final airtight case to the judge, or, in this case, the examiner.
And speaking of presenting your case, this brings us to an absolutely crucial point about presentation. You must follow strict mathematical conventions. We're talking absolute precision with your terminology. We're talking appropriate formatting, like making sure your equal signs align nicely down the page. We are talking clear annotation of your steps, for instance, explicitly stating substituting equation 1 into equation 2. The examiners specifically note that practical application here is actually about developing professional skills. Think about it. If your work looks like a chaotic, messy draft, it completely hides your brilliant logic. Clean, professional formats are what allow your analytical depth to actually shine through and get rewarded.
Section 3. Critical Examiner Warnings. The top 3 traps.
All right, pay close attention here, because these are the 3 biggest offenders extracted straight from the thousands of grading reports. Bar 1, vague details. Students are simply not being specific enough when declaring their variables or defining their boundaries. Bar 2, poor presentation. As we literally just discussed, if the examiner cannot easily track your algebra from line to line, they simply can't reward it. They aren't going to spend 5 minutes deciphering your scribbles. And bar 3, ignoring context. This one is huge. Answers are so frequently given in a complete vacuum, totally disconnected from the specific geometric or physical constraints provided in the original question. If a length calculates to a negative number and you don't reject it based on the physical context, you lose the mark. And hey, stop scrolling for just a second. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve, so join them right now.
Let's actually contrast these two approaches. A flawed approach involves those vague, superficial answers lacking specific context. Doing this will quickly, and I mean very quickly, tank your grade. Conversely, what examiners are desperately looking for, what they want to give marks for, are specific, context-driven answers that utilize comparative logical connectives. You want to use words like therefore or because to clearly signal exactly why one step leads to the next. That proves to them that you understand the underlying mathematical relationship rather than just executing some memorized algorithm on autopilot.
Section 4. Evaluation. The top scoring mindset.
So what do the A-star students do differently? Well, top-scoring candidates share these exact mental habits. They don't just act like human calculators, they actively evaluate. They question the assumptions made in the problem. They consider different mathematical perspectives. For instance, going back to context, they identify limitations, like realizing, as we said, that a calculated negative length literally cannot exist in a physical geometry problem, and therefore they explicitly state that that specific root must be discarded. And most importantly, they justify every single one of those decisions with hard, mathematical algebraic evidence.
When a specific exam question requires a comparative analysis, a massive key here is to identify both the similarities and the differences. You must bridge your ideas together and draw really robust, undeniable conclusions about the relationships between different equations or graphs. And remember, every single claim you make must be fully supported by the numerical or algebraic evidence you just finished calculating. You can't just guess. This is the ultimate undeniable proof of that analytical depth we've been talking about.
Section 5. The Method Mark Strategy.
Please, if you remember only one thing from today, commit this examiner alert to your permanent memory. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. This is an absolute non-negotiable golden rule for the Cambridge exams. Think of it as your ultimate safety net. If you only write down the final numerical answer and you happen to make one tiny silly arithmetic error halfway through, you get 0. Nothing. But if you show all your structured, logical steps clearly down the page, you will salvage precious, precious points, because the examiner can see that your mathematical reasoning was actually perfectly valid.
The crucial, foundational point is exactly this. Process equals marks. In these advanced, additional mathematics topics, method marks are awarded specifically for the rigorous, analytical process you undertake. Your mathematical journey through the problem is just as vital, sometimes even more so, than your final numerical destination. So please, always show you're working clearly, logically, and professionally.
So the very next time you sit down at your desk to do a practice paper, I want you to ask yourself, are you leaving crucial method marks on the table just by hiding your analytical working? Don't do it. Take this examiner's blueprint, the strict professional conventions, the specific context-driven logic, the highly visible logical steps, and apply it to your very next study session. You will see the difference immediately. And as a final reminder, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Drop a comment below with your target grade for mathematics and the absolute biggest challenge you're currently facing. Our team reads and responds to every single comment. Thank you so much for joining me on this explainer. Keep practicing those multi-stage problems, and I will see you next time.